Okay, so what I've been doing, besides doing a whole lot of testing, after, geez, I don't remember what the last thing we ran into. All right, changed the power supply, took care of this. Now, what happened is, I took the board and I put it in and gave it a shot, and it worked pretty well, except for one major thing. We were getting some massive, what they call parasitic oscillations. And what that it does is an oscillation is the voltage and the current is just starts going back and forth, back and forth, back and forth really quickly. And it's all wasted energy and a lot of it. So something was definitely wrong with this. This is the output amplifier section, and what that would explain is, if you remember up here, these burned out resistors. I took them out and they were like toast. I can't find them. I'll see if I can find them later. I mean, they were toasted, black, just awful. So I replaced them with these honkers here. Same resistance, twice the wattage. So that definitely won't happen again. But that is what they call a that's a symptom. It's not the actual cause, because something made this go that route. I mean, made it burn up. And parasitic oscillations will do that. It's almost like you can listen to the radio and you hear the same sound, but for some reason it's using 300 times more power than it should be using. So what would cause that? Because these are going out to the output transistors. These guys here. There we go. Better? Nope. Better. What? Aha. Yeah, right. So 1, 2, 3, 4. Now, when I first took this apart, I noticed that those were replaced sometime in the past by somebody else. Okay. So I checked them, and it looks like the ones that they replaced them with, those NEC transistors, were the wrong kind. And I think that's what was causing the parasitic oscillations. So this thing should be focusing. Focus. Where's the focus button? Oh, there we go. So these things are causing I'm pretty sure these are causing the parasitic oscillation. So I went ahead and I got the right ones and put them in there. They're all set. There's the new resistors over here. I changed out the noisy pots for these pots, which are a lot quieter, and also the other pots were just like one turn all the way around. These are 12 turns, so you can get really, really fine voltage values. When I took the other ones out, I measured them so that these are set the same way. Now I'm still going to have to fire this thing up and balance them and make sure the voltages are correctly set with the new pots, but that's okay. So that's essentially next. I'm going to go ahead and put this back in with the new parts, and it should work. I think that's going to be the last thing I'm going to have to do to this, and I sure hope it is, because I got other ones I need to start on. Yeah. Well, any event, that's what's going on. Okay, let me show you a very important tool in my arsenal over here. Cost me like $10. So, this regular old light bulb here, socket here, And what I'm going to do here, I need to put another socket for the plug to plug into, but in the meantime I'm just going to use this. So what I'm going to do is, the way this works, the switch here, if I switch it up, click once, the power goes through the light bulb and into here and into the amplifier, and so it acts as a current limiter. If something's wrong with the amplifier, the light bulb will glow at full brightness, and then we know there's something shorted, and the voltage drop across the light bulb stops the amplifier from burning up. So what we're going to do, when I plug this thing in, turn this thing on, check the light bulb. It should get bright and then get dim and either go out or almost completely go out. And what that is it goes bright in the beginning while them huge capacitors are charging, because all that current's going in there. And once they become fully charged, the current should go way down, and the light bulb should almost go out, or depending on the amplifier. Sometimes it'll go all the way out, sometimes it doesn't, depend, if the amplifier is drawing a lot of current. So what I'm going to do here is I'm going to plug this in. Now, I put the board in, I soldered it in. I'll tell you, you've got the most labeled board in existence, I think, now. You see, the board's in, it's all soldered on. I'm going to turn it on real quick, see what happens to this light bulb, make sure it goes out when it's supposed to. And let's see, here we go. And that's going to tell us if everything is wired properly. It's essentially what it's going to do. And after that's done, I'm going to take the fluke over here, the multimeter. I'll probably take 2 multimeters and go ahead and hook them up and adjust them pots that we were looking at before, that I said I replaced, to get the voltages correctly set. Okay, so let's plug this in. Okay, so it's powered here. Let me make sure this is turned off for now. Down, I think is off. Let me check the, yep, down is off. Let's make sure the speakers are disconnected. Don't want a lot of extra anything in here. Okay, so let me just, it's not hot yet, so that's not going to hurt anybody. And we're only going to do this test real quick, and if it works, then we move on. No, I'll just plug it in directly. Okay, so starting off, I'm going to click it, the first click, and it's going to put the light bulb into the circuit. Okay, the light bulb's into the circuit, but this thing's turned off. The amplifier's turned off, so no current is being drawn. I'm going to turn the amplifier on, and the light should come on, and then it should get very dim or pretty much turn off. Let's see what happens. Dimmer, dimmer, dimmer. There we go. So this thing is drawing current. The light is on a little bit, which shows you it's a big amplifier and it draws a lot of current, which is why the light doesn't go all the way out. But where it is just fine. Now I'm going to adjust the voltages, which I can't do with this in the circuit because this is dropping the voltage, so it definitely won't be correct if I leave that in the circuit. Okay, so, well, I can flip this up again and it'll go straight through like that. Now it's full power to here. And this is no longer in the circuit. and I don't see any problems at all. So I'm going to take this out and put it away before I zap myself, and then get to calibrating those pots. Alrighty. Seems to be more issues. So yours, the one I've been working on, is over there. Alright. This is another one I bought about the same time. This one is bad in all kinds of different ways. But I think I can rob this one to get yours going. And if you look here though, I mean, this one, yours over there looked like it was kept in the basement somewhere, you know. This one was definitely kept in a garage or shed or something, some storage shed or something like that. You can see there's like mouse turds in here and all that. I vacuumed it out, but there's still a lot more to go here. So I'm gonna see what I can do with this one, see what's good, what's bad, and what's indifferent, and maybe I'll get one good one out of the two. Now if you look at this one here, the big capacitors are starting to leak, so they have to change right away. But you know, on this side it doesn't look too bad, which is kind of cool. So now I did try to test it real quick with the light bulb current limiter, and unfortunately it didn't work so well, but that's probably because the capacitors and all are shot. Anyway, so I'll keep you posted. It's perfect condition. I don't see any discoloration here. I don't see anything that's bad. So whoever used this didn't like to crank it up as much as I used to. Still do, actually. All right, so this is done and off. Let me put this aside here. We're going to here. Now we've got some more access in here. Now I don't want to take this board out if I don't have to, because I don't really feel like undoing everything. But boy, is it dirty. Oh my goodness, look at that crap. You know, I'll probably have to take this thing, bring it outside, vacuum it, blow it out, whatever has to be done. I certainly can't keep it like this. I better keep washing my hands. I know this has got to be mouse urine and everything else in there. Alrighty. Okay, so for the next part, let's say we get that board up there out. Oops. Cord's pulling. All right. Mark and remove. What's the mess in there? This looks so different than the other board. It is a little different. That's interesting. So, one of them must be a newer rev than the other one. take a look at the serial number and see what it is. Which one's newer? These, no, I don't know if you can see that. Nope. So down here, make sure it's okay. See these little tabs are broken off here. That's what happens when plastic gets old. It gets brittle. And this board and where is it? This guy here is completely loose. Boy, was it day and night when you turn this thing around, huh? This side looks beautiful. And then this side is just, sheesh, you gotta be kidding me. Alright, I'm gonna go blow it out.